Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveri Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches and class 6th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th. Today, we are going to start a new chapter, that is chapter number 7, electricity. So today we are in the session number 1. This is the last but one chapter. After this, there is one more chapter is there. So after finishing total chapters, we'll have the revision session where we'll solve all the levels of problems given in the material, right? So before that, before starting this chapter, electricity, let us see what is the prehistory of electricity, how the word electricity comes. So when you want to study anything, you should know what is the origin. What is the origin of this particular word electricity? So it is not now, it's long back. It's around 600 BC. Around 600 BC, that is 2750 years back, the word electricity is used by a great scientist called Thales. He's a scientist, Greek scientist. He's a Greek scientist who used the word electricity and who observed the electricity, that is called static electricity, is first observed by, see here, by rubbing the amber with fur. Amber with fur, right? When amber is nothing but one kind of stone, a sky blue colored stone. When the stone is rubbed with the fur, animals' hair, that is, whenever this stone and hair are rubbed with each other, he observed that both are attracting each other. That means both amber and fur getting the opposite charges. Not only these two, he tried with many more objects. He taken the glass rod, silk cloth, cat's skin and glass rod. So many combinations they tested the materials which are available in that time. And what they observed is when the two bodies are rubbed with each other, both the bodies are getting the opposite charges. One is getting positive charge, one is getting negative charge. That time only they given statement that there are two types of charges, positive and negative. So why they are getting charges? For that again further studies are going on later. There are so many studies are going on when the magnetism comes. What they thought is when the two bodies are rubbed, one body is giving electron, one body is donating electron, one body is accepting electron. The body which is donating electron will get the positive charge. The body which is accepting electron will get the negative charge. Like that, both the bodies will get the opposite charges, right? One is positive, one is negative. So they both will attract each other. Right? And such electricity that time is named as static electricity. Right? Static electricity, because it is forming at the same place. Without movement, without motion, electricity came. Static electricity. The same thing when electrons start flowing. When electron flows from one place to another place, the electricity comes, is called current electricity, what we are using. We all know electricity is nothing but current. What is current? Flow. In static, there is no flow, only transfer. But in current, there is a flow. flow through wire. Suppose if you switch on the light here, switch is here, but light will come there. Or switch is here, fan will move there. Why? Because they are connected to wire. Through the wire, electron will flow or charge will flow and makes the bulb to blow or fan to rotate or geyser to produce the heat. All these are because of flow of charges. Flow of charges. So there are two types of charges are there. One is positive charge, one is negative charge. That is not today. Around 2750 years back at 600 BC, before Christ. 600, 599, 598, after coming there, it will come to 0. After 0, we start 1, 2, 3, 4. Now we are 2026. That is called AD. Before Christ, after the death of Christ. They are taken as two eras. So this property is observed long back by a Greek philosopher, Thales. Clear? So electricity is not a new phenomena. In ancient times only, by studying the thunders, even through thunders also electricity comes. Right? Thunders of Nile. That is called electric fish. From that also they produce the electricity. So this is the just only overview history. Overview. There is a deep history is there. After this again, one more era started. Some Ampere came, Gilbert, scientist Gilbert, Ampere, then Newton. So many of them, they are taken out the what Thales first observed, they developed. Now we are enjoying the electricity. Right? It may be coming from batteries, or it may be coming from transformer. It may be coming from powerhouse, or generator, or inverter. All these are bases 600 BC by Thales. Right? So, for the first time, the word electricity is actually in Greek, it is nothing but electron, means amber. That amber is termed in the Greek as electron. As amber is nothing but stone. That time is used to an electron. From that they derived the word electricity. As first time that is seen when this amber is rubbed with the fur, animal's hair. Clear? So this is electricity produced by the thunder. Through thunder, see how color came? That is current. When the two clouds are crash with each other, thunderstorms will come. That is because of the production of electricity. There is a transfer of electrons takes place from one cloud to another cloud, which results for the storm. Correct? Okay. So before going for the further material explanation, right? So this is our chapter, page number 104, probably 105. You can take out. So before starting this, just I'll show you one video on the basics of the electricity. History. Just what I told, you can see here.
The fundamental force of nature that has shaped the modern world in ways that our ancestors could not have imagined. From the first observations of static electricity in ancient times to the complex power grids that fuel our cities today, the story of electricity is a testament to human curiosity, ingenuity, and perseverance. This video will take you on a journey through time, exploring the key discoveries, inventions, and innovations that have brought us to our current electrified age. So ensure you watch to the end. Let's get started. The story of electricity begins long before the modern era. Ancient civilizations observed electrical phenomena in nature, though they lacked the scientific understanding to explain what they saw. As far back as 600 BCE, the ancient Greeks made one of the earliest recorded observations related to electricity. Thales of Miletus discovered that when amber was rubbed with fur, it could attract light objects like feathers. This phenomenon, which we now know as static electricity, was seen as a magical or divine property at the time. The word electricity itself comes from the Greek word for amber, electron. For centuries, this curious property of amber remained a mere curiosity, with little practical application.
PM Energy Solution. Leading innovation for a cleaner tomorrow. Eco-friendly energy, shaping the
Nowadays, we are
future with
using
electric
electricity even for
mobility.
the
Driven by
vehicles. Bikes
While
are
not
prepared with
directly
electricity.
related to electricity, the study of magnetism in the Middle Ages laid important groundwork for later electrical discoveries.
Right.
In particular, the invention of the magnetic compass for navigation in China around the 11th century CE demonstrated the practical applications of natural phenomena. As the scientific revolution began to take hold in Europe, more systematic studies of electrical
Even
phenomena
started
emerged.
long back.
In 1600, English physician William Gilbert
Gilbert.
published De Magnete, a groundbreaking work that laid the foundation for the scientific study of electricity and magnetism. Gilbert coined the term electric to describe the property of attraction caused by friction, distinguishing it from magnetic attraction. He also identified other substances besides amber that could produce this effect. In 1660, German physicist Otto von Guericke invented the first electrical machine. It consisted of a sulfur globe that could be rotated and rubbed to generate static electricity. This device allowed for more controlled experiments with electrical phenomena. The 18th century saw a flurry of electrical discoveries and inventions as scientists across Europe and America became increasingly fascinated with this mysterious force. In 1729, English scientist Stephen Gray made a crucial discovery about the nature of electricity. He found that electrical charge could be transferred from one object to another through certain materials, which he termed conductors. This discovery laid the groundwork for understanding how electricity could be transmitted over distances. In 1745, Dutch scientist Peter van Musschenbroek invented the Leyden jar, the first device capable of storing an electrical charge.
Store electricity.
This simple capacitor,
Like
consisting
a
of a
battery
glass
before
jar with metal foil on the inside and outside, allowed scientists to accumulate and store larger amounts of static electricity for experiments. Before I continue, if you are new to Inventions Flex, please subscribe below and turn on the notification so that you don't miss out on our great videos on ancient and modern tech inventions. Having said that, let's dive back in. One of the most famous figures in the early study of electricity was American polymath Benjamin Franklin. In 1752, Franklin conducted his legendary kite experiment, demonstrating that lightning was a form of electricity.
See,
He also introduced the concepts of positive and negative charge and invented the lightning rod, a practical application of his research that saved countless buildings from fire. In the 1780s, Italian physician Luigi Galvani made a curious discovery while dissecting frogs. He noticed that the frog's leg muscles twitched when touched by a metal scalpel during a lightning storm. This led him to propose the idea of animal electricity, suggesting that electrical energy was intrinsic to biological processes.
10 minutes and
Okay.
a big basket. 10 minutes
so
and
see,
a
there
big
is so much
basket.
there about the ancient, this one. So we'll see this in next again continuation because there is a big big branch of science, electricity, where there is a lot of history is there. So you see, already we have seen that even long back around 600 BC, after discovering that magnetism, slowly electricity also observed by many scientists from that time to recent times. One by one, stepwise, they improved. It may be Gilbert, or it may be Franklin, and they have performed so many experiments. They designed so many devices to store the electricity before our battery or cell, right? Like a stepwise, electricity is developed, and now we are enjoying the so many applications of electricity in our day-to-day life. Even we cannot imagine our life without electricity. If power goes for a minute, we'll get a lot of tension. One is mobile charging. Second one is maybe air conditioner or maybe TV or maybe any other technology usage. So that much importance is there in electricity and our day-to-day life, right? So now we'll start with some important terms which we regularly use, in the electricity, right? So after knowing about basic background history, now we'll come to some important terms. So starts with the electric cell, right? So electricity is nothing but flow of charge from one place to another place. That is electricity, no doubt. Flow of charge per unit time is electricity. That is, mathematically, if you see, I is equal to Q by T. That we'll see later. Flow of charge, either positive charge or negative charge, when flows from one place to another place, electricity is produced. Just like when switch on, the power light on. So charge is flowing through wire and it is reaching the bulb, right? So cell, an electric cell consists of two terminals. One is positive, other is negative. You know, everybody, cell is, you can see cell, which you can use for the watch or remote control, right? The small one is 1.5 volt. Cell is always carries the power of 1.5 volt. If you combine the cells, it is called battery. When two or more cells combined, it is called as battery, little bigger one. It may be 3 volt, 6 volts, 9 volt, batteries will be there. But when one positive and negative combined, it is called cell. It is symbol is like this. You can see symbol like this. The long one is positive, the short one is negative. They are connected like this. Is called a symbol of cell. So an electric cell consists of two terminals. One is positive, one is negative. An electric cell produced with the chemical that helps to produce the electricity to the connected devices. Whether you are running tape recorder or radio or a TV or remote control or anything, everything where you are using this cell is produce the current by chemical energy. In every cell, chemical energy is converted into electrical energy, right? So it contains the chemical, it converts into electrical, right? The chemical paste, remember chemical paste as a cell or battery, okay? It's a very important component of electricity. Very important component of electricity is electric cell, right? The second one is bulb. You know, is also very important component. A bulb consists of two terminals. A filament is a spirally wound wire inside the bulb. See, this is called a filament, generally made up of a good conductor of heat, that is tungsten, and supported by two thick wires at its ends. These two are the thick wires to which it is connected to bulb. An electric cell is connected to the terminal of the bulb so that electricity from the cell can pass through the bulb. This electricity makes the filament in the bulb to glow and emit light. So when this bulb is connected to battery here, this end of the bulb is connected to battery. One is positive, other negative. Then current goes to that and makes the tungsten to heat and it produces the. So this is a symbol of the bulb. So symbol of cell is this. We can represent cell by positive and negative, and this is for the bulb. That is filament shape. This is for bulb. This is cell. This is bulb. Which are the two important components of the electricity, right? Then now we'll come to some more information about the cell and torch. Okay, you can see here. Electric cell and torch bulb. An electric cell is a device that supplies electric energy to the devices that functions using the electricity. Thus, an electric cell produces electricity for a torch. An electric cell provides the electricity to the number of devices like toys, alarm clock, and so many things. Wherever you use the bulb, wherever you use the cells, they produce the electrical energy and gives out to the devices like bulb, toys or clocks, remote controls, everything. So an electric cell has a cap just under which there are plus sign. This is the positive terminal of the cell. There is a flat metal disc with minus sign just above the disc. You can see this clearly. Here positive, here flat is the negative. Okay, disc. This metallic disc is negative terminal of the cell. These terminals of the cell can be used to connect to the various devices. Inside a cell, there is a dark powdery stuff inside. There is a powdery chemical stuff will be there, which is chemical helps the cell to provide electricity to device is connected to. Right? So this is symbol I told you, this is a symbol of electricity. Symbol of bulb. Original cell look like this, original bulb look like this. But the symbols can be like this. Symbolic representation. So when you are connecting this positive terminal to the other negative terminal of any other device, from, for example, it may be wall clock, or it may be bulb, or it may be toy car, we'll connect the device to the in a given manner so that you can get the electric current. Right? Then, so before going for the next, let me show you one video on same about some introduction part of electricity.
Hello friends, what do we need to run our television set, refrigerator, DVD players, video games, computer and fax machines? Yes, it is electricity. Electricity has always been around because it naturally exists. Lightning, for instance, is simply a flow of electrons between the ground and the clouds. Objectives. At the end of this lesson, you will be able to define electricity, establish the relation between electric current and charges, identify the two types of electricity, define conductors and insulators. How do you study in the late evening? Of course, you light up your room using an electric bulb. Have you ever wondered what causes the bulb or the tube to light up? They need electricity to light up. Electricity passes through the wires and reaches the filament of the bulb, heating it up to glow. When we comb our hair with a plastic comb and take it near the small pieces of paper, the paper pieces are attracted toward the comb. We then say that the comb is charged with electricity. This was first noticed by a Greek man named Thales over 2,500 years ago. Thales found that amber attracted tiny feathers after it was rubbed with silk cloth. This was due to static electricity. The origin of the word electricity comes from the term electron. Let us perform an activity to understand positive and negative charges.
Very important.
Take an ebonite rod and rub it with a piece of woolen cloth. Now suspend the rod by tying a thread through its middle. Now charge another ebonite rod in the same way and bring it close to the suspended rod. What do you notice? The suspended rod moves away from the second one.
Repulsion.
Now take a glass rod and rub it with a silk cloth. Bring this glass rod close to the charged suspended ebonite rod. What do you observe now? The suspended ebonite rod comes closer to the glass rod.
So unlike
The charges produced in the ebonite and the glass is different in nature. These two kinds of charges are called positive and negative charges. The positive charge is shown by the plus sign and the negative by the minus sign. Merely as a convention, charge on a glass rod rubbed with silk is taken as positive and that of ebonite rod rubbed with woolen cloth is taken as negative. From the earlier activity we can conclude that like charges repel each other and unlike charges attract each other. Fill in the blanks. We have just studied about electric charges and the forces they exert on one another. We have learnt there are two types of charges, positive and negative. When charges transfer from one body to the other, the bodies are said to be charged. The moving or flowing charges produce an electric current. An electric current consists of a movement of negative charges, that is, electrons. The flow of electrons gives us electricity. Electric current is measured by ammeter. Dry cell battery used in a torch or transistor radio is a source of electric current. Every battery has two terminals marked plus and minus. When a metallic wire connects these two terminals, the electrons resulted from chemical reaction start flowing through the wire, constituting an electric current. These electrons flow from the negative to positive terminal.
See,
Thus,
for next topic, this is. There are so many things you can see: iron, graphite, copper, aluminium, brass, silver, gold. What they are all? They are all allows the light to pass through them. The materials which allow light to pass through them are called conductors. What they are called? Conductors. So metals like iron, copper, brass, aluminium, silver, all they are called conductors of electricity. Means they allow the current to pass through them completely. That is our next part actually.
a cell is a simple device in which chemical energy is changed
What is
into
cell?
electric energy. Some materials allow electric current to pass through them. Others do not.
So paper.
The materials that allow electric
They won't allow. See, paper is there, cloth, plastic, eraser, wood. They won't allow the current to pass through them. They are called insulators, or non-metallic conductors are called insulators.
current to pass through them are called conductors. Iron, copper, brass, aluminium, silver, gold, graphite, etc. are the conductors of electricity.
Pencil.
The materials
steel.
through which electric current doesn't flow are called insulators. Insulators are also known as non-conductors of electricity. Paper, wood, plastic, cloth, eraser, rubber are the insulators. Pencil lead is made of graphite. It is a form of carbon. It is non-metal, but it is a conductor of electricity. It can be tested whether a given material is a conductor of electricity or not. The given material between the free ends of wires in an electric circuit face the given material between the free
it's
ends
not
of
very
wires in an electric circuit.
Avoid the shocking.
Bring the free ends of the two wires close.
So what we learn in the
Now
home-
let them touch each other. If the bulb glows, the material is electrically conducting, otherwise it is an insulator. Both conductors and insulators are important while using electricity. The conductors like copper or other
See, these are the different
metallic
points what
wires
we
are
learn.
used for electric supply, but at the same time, these metallic wires are coated by insulating materials like plastic or rubber for safety. Summary.
Right? These are all the
Let us
important
summarize
points what we learn in
what
the
we have
video,
learned.
which covers
Electricity
what
is
we
a
covered in
form
the-
of energy.
Okay. So everything is covered. What is the basics? What we have seen the prehistory of the electricity, where comes from the word Greek letter electron, which is nothing but an umber, one kind of stone. When it is rubbed with the different objects like fur, silk cloth, glass rod, they are both attains the charges because of the transfer of electrons. So transfer of electrons or transfer of charge per unit time is called as electricity. Mathematical formulas will get in the higher classes. And we have seen what is electric cell. Everybody know cells will use in the remote control, or will use in the radios, will use in the various electric appliances. So it is a chemical energy. That chemical energy is converting into electrical, then make the torchlight to glow, make the remote control to operate the systems and make the radio to give the sound for us. All these things because of the cell only, which contains two terminals, positive and negative. Right. Then bulb, which is a source of consumer of electricity. The cell is called source of electricity. Bulb is called consumer, which utilize the current. Bulb, refrigerator, AC, all these comes under the consumers. Okay. Consumers of electricity. So, source and consumers. Source and consumers are very important for running the. Okay. So then we have seen just a brief in the video, which we'll discuss in the next class about what are conductors, what are the insulators, and what is earthing. Why you will get the shock sometimes at home also when you go and touch fridge during the rainy season, especially when you touch the fridge or when it's at any electric appearance, you will get shock. That is because when earthing is not there. What is the importance of earthing and what is electric circuit? All these things we can learn in the next class, right? So this is just introduction part of the electricity where we learn about what is electricity and what is the components of electricity, like electric cell, which is called source of electricity, electric bulb, which is the consumer of electricity. Consumer, source and consumer. These two are very important. If there is no source, no use. There is no consumer, there is no use. These two are plays very important role to produce the light or to produce the sound, to produce the heat. Everything, these two are important, right? So that's all for today. In next class, we'll discuss in deep about what are the insulators, conductors, what is electric circuit, how to get the electric circuit. See, in our house, it is connected to the electric circuit only. All the wire you cannot see outside because wires are kept inside, concealed. And that wire goes and connected at one point to the bulb or one point to the fan. So that those two wires are connected to switch again. When you switch on the fan will move. Or when switch on the AC will come. All these are internally connected through wire. That is called circuit. Connecting electric meter and all the electric appliances through wire, which we cannot see from outside, but internally they are connected. So that are what circuits. They are connected to fuse. If you switch on one fuse, one room light will go. If you switch on other light, the other light also will go. So all the room connections are connected to one fuse. That is called circuit. Yes. So in details we'll discuss in the next class. Right. So this is the electric thunder. So that's all for today. Thank you, students. Have a wonderful day. Thank you.